I'm Mark Allen Doctolero.
I'm Elame Ingratian. And Delson May Cantina.
And I'm Clarence Noel.
And we're here to discuss about special products. Greetings everyone! We're here to discuss one of the most common topics in college algebra, the special products.
We will discuss about the things that we should learn about special products and how to derive the answers. Grab your pen and papers and learn with us on how special products works.
But before we discuss how special products works, let's first define what special products are. Polynomials can be multiplied, resulting to special products that are defined as square of the sum or difference of two terms and product of the sum or difference of two terms.
There are many types of under special products. These types are classified by the given factors.
Some of these types are the product of two binomials, the product of the sum and difference of two terms, square of a binomial, cube of a binomial, and the product of a special case of multiplying a binomial and a trinomial.
Special products can be also factored back to the polynomials with common monomial factors, difference of two squares, sum and difference of two cubes, perfect square trinomial, and general trinomial.
The first step that we're going to discuss is the product of two binomials. To multiply two binomials, we have to use the FOIL method. FOIL stands for firsts, outers, inners, and lasts.
For example, we have quantity A plus B times the quantity C plus D. The first thing we are going to multiply is the first term of each binomial, which is A and C. The second terms we're going to multiply is the outer terms, which is A and D. The third terms we're going to multiply are the inner terms, which is B and C. The last thing we are going to multiply is the last term, which is B and D.
After doing the FOIL method, the equation will be equal to AC plus AD plus BC plus BD. The operation for each term depends on their operation after being multiplied. Now grab your pen and paper and we will have our examples.
Consider we have quantity x plus 6 times x plus 7. We will apply the FOIL method and we will be starting by multiplying the first terms that will result to x squared. Next is outer terms that will result to 7x. Third is the inner terms that will result to 6x. And last term that will result to 42.
Therefore, quantity x plus 6 times quantity x plus 7 is equals to x squared plus 7x plus 6x plus 42. The last thing that we're going to do in FOIL method is to combine similar terms. In the equation, 7x and 6x are similar terms, and when combined, it will result to 13x.
Now that we have combined the similar terms, the whole equation will be equal to x squared plus 13x plus 42. That's how to do the FOIL method. Let's try another one.
Consider we have quantity x plus 6 times quantity x minus 7. Do again the FOIL method and we will start by multiplying the first terms that will result to x squared. Next is outer terms that will result to negative 7x. Third is the inner terms that will result to 6x. And last term that will result to 42.
Therefore, quantity x plus 6 times quantity x minus 7 is equals to x squared minus 7x plus 6x plus 42. The last thing that we're going to do in FOIL method is to combine similar terms. In the equation, negative 7x and 6x are like terms and when combined, it will result to negative x.
Now that we have combined the like terms, the whole equation will be equal to x squared minus x plus 42.
Is that FOIL method easy? You just have to follow the patterns first, outer, inner, last, and combine similar terms to get the simplified forms of the binomials.
There are two types of binomials in special products. These are difference of two squares and square of a binomial.
Now we will be discussing the difference of two squares. So grab your pen and paper and follow what we're going to do.
Consider we have quantity a plus b times quantity a minus b. In multiplying these binomials, we will use the FOIL method again, and quantity a plus b times quantity a minus b is equals to a squared plus ab minus ab plus b squared. Simplifying this will be equal to a squared minus b squared, since positive ab minus ab is equals to 0.
We will have another example of difference of two square given quantity x plus 6 times the quantity x minus 6.
Again, we will use the FOIL method to derive the simplified form of two binomials.
Quantity x plus 6 times quantity x minus 6 is equal to x squared minus 6x plus 6x minus 36 when we apply the FOIL method.
Simplifying further, the equation will be equals to x squared minus 36, since negative 6x plus 6x is equal to 0.
Let's have some more examples of difference of two squares. Consider quantity x plus 4 times quantity x minus 4. This equation will be equal to x squared minus 4x plus 4x minus 16 when we use the FOIL method. Combining similar terms, the equation will be equal to x squared plus 16 since negative 4x plus 4x is equal to 0. Consider quantity x plus 3 times quantity x minus 3. This equation will be equal to x squared minus 3x plus 3x minus 9 when we use the FOIL method. Combining similar terms, the equation will be equal to x squared minus 9 since negative 3x plus 3x is equal to 0. Consider quantity x plus 7 times quantity x minus 7. This equation will be equal to x squared minus 7x plus 7x minus 49 when we use the FOIL method. Combining similar terms, this equation will be equal to x squared minus 49 since negative 7x plus 7x is equal to 0. Consider quantity x plus 6 times quantity x minus 6. This equation will be equal to x squared minus 6x plus 6x minus 36 when we use the FOIL method. Combining similar terms, this equation will be equal to x squared minus 6 since negative 6x plus 6x is equal to 0. Consider quantity x plus 5 times quantity x minus 5. This equation will be equal to x squared minus 5x plus 5x minus 25 when we use the FOIL method. Combining similar terms, this equation will be equal to x squared minus 25 since negative 5x plus 5x is equal to 0.
Now let's move to our second type of binomials under special products, the square of a binomial.
Let's have some more examples on square of a binomial. Consider we have quantity x plus 10 squared. This equation is equal to quantity x plus 10 times quantity x plus 10 when expanded. By using FOIL method, the equation will be equal to x squared plus 10x plus 10x plus 100. Combining similar terms, the equation will be equal to x squared plus 20x plus 100, since 10x plus 10x is equal to 20x. Consider we have quantity x plus 4 squared. This equation is equal to quantity x plus 4 times quantity x plus 4 when expanded. By using FOIL method, the equation will be equal to x squared plus 4x plus 4x plus 16. Combining similar terms, the equation will be equal to x squared plus 8x plus 16 since 4x plus 4x is equal to 8x. Consider we have quantity x plus 13 squared. This equation is equal to quantity x plus 13 times quantity x plus 13 when expanded. By using FOIL method, the equation will be equal to x squared plus 13x plus 13x plus 169. Combining similar terms, the equation will be equal to x squared plus 26x plus 169, since 13x plus 13x is equal to 26x. Consider we have quantity x plus 8 squared. This equation is equal to quantity x plus 8 times quantity x plus 8 when expanded. By using FOIL method, the equation will be equal to x squared plus 8x plus 8x plus 64. Combining similar terms, the equation will be equal to x squared plus 16x plus 64, since 8x plus 8x is equal to 16x. Consider we have quantity x plus 7 squared. This equation is equal to quantity x plus 7 times quantity x plus 7 when expanded. By using FOIL method, the equation will be equal to x squared plus 7x plus 7x plus 49. Combining similar terms, the equation will be equal to x squared plus 14x plus 49, since 7x plus 7x is equal to 14x. Now we know how to derive the simplest form of the type of binomials.
The next thing that we're going to discuss is the cube of a binomial, which has a given equation x cubed plus 3x squared y plus 3xy squared plus y cubed.
We are going to substitute the first term of the given binomial to the x variable and the second term to the y variable, then simplify the whole equation.
Consider we have quantity a plus b cubed. That is equal to quantity a plus b times quantity a plus b times quantity a plus b. We will use the formula x cubed plus 3x squared y plus 3xy squared plus y cubed and substitute the terms to the variables.
We will substitute a from quantity a plus b cubed to x and b to y. The equation will be equal to quantity a cubed plus 3 times quantity a squared times quantity b plus 3 times quantity a times quantity b squared plus quantity b cubed.
Simplifying further, the equation will be equal to a cubed minus 3a squared b plus 3ab squared minus b cubed.
The equation quantity a minus b cubed will be equal to quantity a cubed minus 3 times quantity a squared times quantity b plus 3 times quantity a times quantity b squared minus quantity b cubed.
As you can see, if the operation of the binomial is subtraction, the operation of the equation will be positive for the first and third term and negative for the second and last term.
Another example, consider we have quantity 3a plus 4b cubed. We will use again the formula x cubed plus 3x squared y plus 3xy squared plus y cubed.
We will let 3a equal to x and 4b equal to y and substitute the terms to the variables and simplify.
After substituting, the equation will be equal to quantity 3a cubed plus 3 times quantity 3a squared times quantity 4b plus 3 times quantity 3a times quantity 4b squared plus quantity 4b cubed. Simplifying further, the equation will be equal to 27a cubed plus 108a squared b plus 108ab squared plus 84b cubed. Let's have some more examples for cube of a binomial. Consider we have quantity x plus 10y cubed. This equation is equal to quantity x plus 10y times quantity x plus 10y times quantity x plus 10y when expanded. The equation for cube of a binomial is equals to 3 cubed plus 3x squared y plus 3xy squared plus y cubed. Substitute the first term to x and the second term to y on the equation 3 cubed plus 3x squared y plus 3xy squared plus y cubed. After substituting, the equation will be equal to x cubed plus 3x squared times 10y plus 3 times x times 10y squared plus 10y cubed. Simplifying, the equation will be equal to x cubed plus 30x squared y plus 300xy squared plus 1000y cubed. And this is the final answer since there are no similar terms to be simplified. Consider we have quantity 2x plus 3y cubed. This equation is equal to quantity 2x plus 3y times quantity 2x plus 3y times quantity 2x plus 3y when expanded. The equation for cube of a binomial is equals to 3 cubed plus 3x squared y plus 3xy squared plus y cubed. Substitute the first term to x and the second term to y on the equation 3 cubed plus 3x squared y plus 3xy squared plus y cubed. After substituting, the equation will be equal to quantity 2x cubed plus 3 times quantity 2x squared times quantity 3y plus 3 times quantity 2x times quantity 3y squared plus quantity 3y cubed. Simplifying, the final answer will be equal to 8x cubed plus 36x squared y plus 54xy squared plus 27y cubed. Consider we have quantity 4x plus 5y cubed. This equation is equal to quantity 4x plus 5y times quantity 4x plus 5y times quantity 4x plus 5y when expanded. The equation for cube of a binomial is equals to 3 cubed plus 3x squared y plus 3xy squared plus y cubed. Substitute the first term to x and the second term to y on the equation 3 cubed plus 3x squared y plus 3xy squared plus y cubed. After substituting, the equation will be equal to quantity 4x cubed plus 3 times quantity 4x squared times quantity 5y plus 3 times quantity 4x times quantity 5y squared plus quantity 5y cubed. Simplifying, the final answer will be equal to 64x cubed plus 240x squared y plus 300xy squared plus 125y cubed.
The next topic that we're going to discuss is the special case of multiplying binomial to a trinomial, which is represented as quantity x plus y times quantity x squared minus xy plus y squared. This equation is equal to x cubed plus y cubed.
This equation is very easy because all you have to do is to substitute and simplify. The first thing that we're going to do is to let the first term of the binomial be equal to x and the second term equal to y.
The second thing is to substitute the first term of the binomial to the x variable and second term to the y variable. After substituting, the equation will be equal to quantity x cubed plus quantity y cubed. Simplifying further, the equation is equal to x cubed plus y cubed.
Let's have another example. Consider we have quantity x minus y times quantity x squared plus xy plus y squared. In this case, we'll be going to use x cubed minus y cubed.
Like what we've done earlier, let the first term of the binomial equal to x and the second term be equal to y. Substitute the first term to x cubed and second term to y cubed. And that's how to solve the special case of multiplying a binomial and a trinomial with a short method.
Now we will discuss one of the most important bases in special products, the Pascal's triangle.
By using the Pascal's triangle, we can easily derive or determine the coefficients of every term of a binomial raised to any real number.
In this representation of the Pascal's triangle, the number on the top represents quantity x plus y raised to 0. It is equal to 1 because any number or variable raised to 0 is equal to 1.
Below the first one is 1 and 1. This represents the coefficients of a binomial raised to 1 because quantity x plus y raised to 1 is equal to the binomial itself. Below 1 and 1 are numbers 1, 2, and 1. These numbers represents the coefficients of each term of a square of a binomial because x plus y squared is equal to x squared plus 2xy plus y squared due to the FOIL method.
Below 1, 2, 1 are numbers 1, 3, 3, and 1. These numbers represent the coefficients of each term of a cube of a binomial, because quantity x plus y cubed is equal to x cubed plus 3x squared y plus 3xy squared plus y cubed.
Below 1, 3, 3, and 1 are numbers 1, 4, 6, 4, and 1. These numbers represent the coefficients of each term of a binomial raised to the fourth power because quantity x plus y raised to 4 is equals to x raised to 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y raised to 4.
Now that we have discussed about the first 5 levels of Pascal's triangle, we can now determine what will be the coefficients of each term of quantity x plus y raised to 5. Let's try. Let the edges equal to 1 since the only number you're going to add is 1. Next step is to add each consecutive coefficients from quantity x plus y raised to 4.
In quantity x plus y raised to the fourth power, we have 1 and 4 equal to 5, 4 and 6 equal to 10, 6 and 4 equal to 10, and 4 and 1 equal to 5.
And there we have the coefficients for quantity x plus y raised to 5. The next thing that we're going to do is to determine the variables for each term.
As we can see to the equation of quantity x plus y raised to 4, which is equal to x raised to 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y raised to 4, the exponent of x increases while the exponent of y decreases. In quantity x plus y raised to 5, our degree is 5, which is the highest exponent for the x and y variable. And we are going to start with x raised to 5 for the first coefficient, which is 1.
Next is x raised to 4y for second coefficient, which is 5. Next is x cubed y squared for third coefficient, which is 10. Next is x squared y cubed for fourth coefficient, which is 10. Next is x raised to 4 for fifth coefficient, which is 5. And last is y raised to 5 for the last coefficient, which is 1.
And that's how to use the Pascal's triangle. Go!
There are two.
Wait lang. Ayaw mapindot.
1, 2, 3.
Now, we will be discussing difference of two squares. Now, grab your pen and pen. Ano?
1, 2, 3.
Now, we will discuss the difference of two squares. So, grab your pen and paper and do what we're... Go!
Now, we know how to derive the simplest form of type of binomials. Mali?
Let's move to our... Now let's... Isa pa nga!
The next thing that we're going to do... Ano?
Okay.
The next thing that we're going to discuss is... The next thing that we're going to discuss is the cube of a binomial, which has a given equation x cubed plus 3x squared y plus 3xy squared plus y cubed.
3.
Ginagano mo si Allen o ako?
It's a game. By using the Pascal's triangle, we can easily derive or determine the coefficients of the terms of a binomial raised to any real number. Okay. Ay, gano'n!
Lang. Go.
Now we will discuss the important